Probability and the Multiplication Rule by Justin D'Souza. The learning objectives of this lesson are to apply the multiplication rule to situations involving independent events and the same thing to dependent events. Now, we will look into what is independent and dependent events in a while. The keywords are compound event, independent, and dependent events. Now, let's look into the lesson here. Compound event is basically event consisting more than two simple events. What exactly is a simple event? Now, event, say you're rolling a die, is a simple event. You're rolling a coin is a simple event. But when there are two events involved, see over here there is a head and a coin. Coin and a die. This is a compound event. And independent events are the events which one's sample space or one's probability is not outcome. Sorry, the outcome is not at all affected by the other thing. Now I'm going to toss a coin and then I'm going to roll the spin over here. These both are just not affecting each other because tossing a coin, if I get head or tail, is not going to affect what I'm going to get over here. They are two independent events. But say, imagine we have a deck of cards and then we take one card and we do not put it back and then another card removed, then this is a dependent event. We will see that in a while. Now, for now, independent events are two separate events which are not affecting each other. In the last slide, we saw a coin being tossed and a spinner having 1, 2, 3 being spun, right? So, what are the sample spaces over there? You can either get head and 1, head and 2, head and 3. It also can be a tail and 1, tail and 2, and tail and 3. So there are how many total possibilities? 6 possibilities. Now here they have told what is the probability of a coin landing on heads and the spinner on 2. So we need to get head and 2. So there's only one possibility out of total desired outcome is only 1. Total possible outcomes is 6. 1 by 6 is the probability. Now this is simple to write, easy, it's fine. Now if you think about a die, say a six-sided die, right? It would have been 6 into 2, that's 12 possibilities. The sample space increases. Every now and then you can't keep on writing this. So how is a better way? The better way is a easier way. That is, what is the probability of getting a head? Out of one option out of two, right? In the coin. And what is the possibility of getting 2 in the spinner? There were 3 total numbers, 1, 2, 3, and there is 1. So just multiply them. That will be your answer, 1 by 6. So now here we can see a formula. The probability of independent events, okay, of 2, A and B. And is very important. And means multiplying. Of independent events is just multiply the probability of A times probability of B. This is only when they are independent. Let's look into some problems here. Anna is a member of gaming website that randomly pays users together to solve puzzles. Of the 50 other players currently online, Anna is friends with 10 of them. Suppose Anna is paired with a player for a game. Not liking the outcome, she disconnects it and is again paired with another player. Okay. Now let me just tell you what's happening here. So she's playing online game to solve puzzles, and there are 50 people online. Green over here, 50 already. And you can make friends with the players and stuff. And already among the 50 who are online, she is already friends with 10. So the total number is 40, 10 she's already friends with. Now suppose Anna is paid. Now she will join and she's paid with someone, but she doesn't like that. So she'll disconnect and she wants to join again. Now, what is the probability that neither player that Anna is paid, is friends of hers? In the sense, first time she's gonna join. It will be a non-friend person. Now, your friends are 10. How many are not friends? 40, isn't it? Out of 50, 40 are not friends. So this is the thing. So first time she joins, there is 40 out of 50 probability that it's not friend. Now again she disconnects and she again joins. Probability of A is what? Probability that both the times it's not friend. So first time it is a not friend multiplied by the probability of B, which is also not friend. So 40 by 50. So there is 2 times P of A times P of B. That is 40 by 50 times 40 by 50. What is the answer? That's your our final answer. That's it. So over here, it'll be just, you can cut all these zeros out, right? Up and down. So it'll be 4 by 5 times 4 by 5. It'll be 4 times 4 is 16. 5 by 5 is 25. And this will be the answer, 16 by 25. I hope this is clear. So you're just multiplying the first and second probability. Here they have already told she is paired with the player of a game. Not liking the outcome, she disconnects and joins again, okay, another player. So what is the probability? Both the time, first and the second events are not friends. So out of 50, 40 are not friends, only 10 are friends. So 40 is the desired outcome, divided by the total outcome is 50 times again 40 by 50. That will be the answer. It's 16 by 25. You can see that's the final answer. You can press calculator SD 16 by 25 and you can find the percentage as well. That will be 64%. Now remember, if you're using your calculator and you press the SD symbol, it'll be 16 by 25, right? 16 by 25. You will get 0.64 and something. Here, when you multiply this by 100, it is 64%. So whenever you see this, directly take the decimal to 2 to the right. It'll be 64%. Directly you can write it. And over here, what are the assumptions do you have to make in order to solve this problem? Now, what assumption did we make? Now, see, for example, when the game started, there were 50 players and 10 of them were friends. We're assuming all the time that's the same condition, but in reality, it won't be the same, isn't it? First time, yes, it'll be the 50, but next time, some of them might have left the game, and some of the friends might reduce or increase. So this is a variability, but we are assuming that it's the same. 50 are the total players, and only 10 are our friends. So that is the assumption we have to make in order to solve this. Okay, because if the number of players or friends it changes, then the probability also changes. Now we have another similar problem. Paula's weather app tells that there is 20% chance of rain on Tuesday and 50% chance of rain on Wednesday. What is the probability of rain on both Tuesday and Wednesday? Probability of T multiplied and probability of Wednesday, Tuesday and Wednesday. What is the probability of Tuesday? It's 20% or 20 by 100 multiplied with what? 50 by 100. So all you need to do is multiply them. This is 1 time, 5 times, 1 time, 2 times, and you have 1 times 1 is 1, 5 times 2 is 10. So it is 0.1% or 1 by, sorry, it is 10%, not 0.1%. It's 1 by 10, that is equal to 0.1 or that is equal to 10%, right? You should take this 1, 2, 1 0 will be added. So any of this is the answer. Let's look at the answer. There's two answers. Okay, these two are written. That is these two, but you can write it as 1 by 10 or 0.1 or 10%. All are the correct answers. I hope this is clear. Now we will look into the probability of dependent events. This is another interesting one. But before that, I just want to quickly remind you, if you have not subscribed to this channel, please do hit the subscribe button. I always ask you to subscribe. The reason is only 10.4% of my viewers are subscribed. This is the recent last month's statistics, whereas 89.6% are not subscribed. So this is the reason why I always say this. And if you have already subscribed, thank you so much. I appreciate it. So please do hit the like button. That would help me a lot. And please do share my videos with your friends, and I would greatly appreciate it. Now, going on to the probability of dependent events. Here, imagine you have a bag. Okay, you can see there is 5 red balls and 2 blue or yellow balls. Okay, now you are picking a ball at random. What is the probability that it will be red? So the probability of red is 5 by 7. Total balls are 7, 5 are red. Very easy to understand. Fine. Now this is the first event. Now the second event is happening. Again, I'm going to pick it random. And this time again, what is the probability of the red ball? It will be 5 by 7 itself, right? The red ball is going to be 5 by 7. But in this case, imagine you take the first, probability, first red ball, you took this ball outside. And what you do is you throw it away. You're not going to put it back in the bag. You're going to throw this away. So this is gone. This is not there. Now there are only how many balls? One, two, three, four, five, six remaining. When you're doing it again in the second event, it's going to be six total balls. And how many red balls are there? Four only. So this is the probability. Now let's go on to a third event. Now this time I'm going to pick a blue ball. What is the probability? Now two balls are gone, okay? The second one also is thrown away. What is the probability for the blue now? How many are there? It reduces by 1 and this is by 2. Now imagine fourth event was again another red ball. Then we know already 3 red balls are there. So it'd be 3 by 5 was there. Now this one is gone. How many are remaining? 4 are remaining. So you can keep on doing this until you get the last one. So now if another red ball, now 3 red balls, one is gone, this is gone in the fourth event. Say 4 events, 4 are gone. Now 3 are remaining. So for the fifth event to get another red ball, it would be 2 by 3. So now again 1 by 2 and lastly 1 by 1. That's how it is. So each time if you're not replacing the ball back, if you're not keeping the ball back, the total number of balls reduces. And look at what is being asked. If it is red, okay, first red was 5, now it's going to reduce because it's gone. So this is what is dependent. Now here dependency matters because the first event impacts the second event. The probability keeps on changing. That is what it is. Now let's look over here to statements whether they are dependent or independent. Now here we have been told a spinner is spun twice. Imagine there is a spinner. We had seen a spinner at the beginning. You rotate it once and imagine it's divided by 4 parts. Okay, I'll just draw a spinner. This spinner is made into 4 parts. Say you have blue color, yellow, orange, green. Okay, and there's a point over here. You spin it randomly and it falls at yellow. Fine. You're spinning it again. Will the first event impact the second event? No, they are really independent because why? Doesn't matter which color you get. The second time again the probability is 1/4. The first time was 1/4. Second time will be 1/4. 1/4. They never impact each other because we are not taking this away. All the 4 colors remain. So this is why this is independent. Okay, it's independent basically. You can see it's independent event. Now, in a raffle, one ticket is drawn from drawn for the first place, and then another ticket is drawn for the second place. Now, raffle ticket is like a lottery ticket. You win prizes for those tickets. So, for one ticket, you got the first place. You can't use it again. It won't be there. Once you get a first place, gone. That's removed. Done. The second time, second place will be out of from the other tickets. Now, imagine there are totally 100 raffle tickets. The probability of winning the first ticket is 1 out of 100. Now the second place, what happens? This is done, right? There are 99 more and 1 out of 99 will be the winner. So from after the first event, the second event is impacted, right? Because the total number of outcomes, total possible outcomes is reduced. So the probability changes. So this is a dependent event. This will be dependent, because the events are dependent on each other, and a random number generator generates 2 numbers. Now this is told a random number generator generates just 2 random numbers. Doesn't matter if the first one is 5, it can randomly generate another number. That doesn't matter, you have the random generator variable generator even in your calculator. You can keep on generating. The probability remains the same. They are independent of each other. So these random generations are all independent. Now here, please try pausing the video and try to solve this by yourselves. I'll read through the statements and you think in your mind and then answer. So of the $100 that Ray has to spend, she wants to spend $59 on a blouse and $44 on some jeans. What do you think is this? Some might think it's independent. Why? Because you're spending on a blouse and spending on a jeans. But here, look at this. The total money is constant. And from this, she wants to spend $59 on of the $100, 59 on a blouse. But if 59 is spent, then this is impacted, right? Jeans you can't spend again 44. Why? If 59 is gone, how much is remaining? Only $41 is remaining. So these are dependent on each other. You can't tell it's independent. Why? Because if Ray is going to spend for $59 on a blouse, then remaining money would be just $41. So not possible to spend $41 on jeans. Okay. So if she spends $44 on jeans, then there'll be only $56 remaining. So this is not possible. So they both are dependent on each other. Now the next question, Ray asks each of the three store associates which handbag they prefer. Okay, now this is independent, I believe, because you're just asking three store associates which handbag they prefer. So it doesn't really make any difference. Like they are separate store associates. Okay, three store associates. Even if they're in the same store, it's just a preference. So it'll be independent. Okay. Now Ray purchases a handbag and a belt. Now here they have not mentioned anything. It's just handbag and a belt. That's fine. It's independent. Handbag is separate, belt is separate. Now we will look into a method how to solve it if a problem is given. We just now deduced which are dependent and independent, but now if you have a dependent problem, how do you solve it? Over here you can see probability of A and B for dependent events are probability of A multiplied by the conditional probability of B such that the A event has occurred. Like one event has occurred and then what's the probability? We will look into a problem like I'll just tell you now. Just now we did, right? There were 7 balls in total. Initially 5 were red. So this is the first probability, 5 out of 7. Now what is the second time? Again you're picking a red ball. Now probability of B with the condition that the first event has already occurred. That means this has already occurred and it's not replaced. So it'll be 4 by 6. This is the condition probability. Next one. Okay. It's just not P of A, P of B. It is B condition A. Now we will solve this problem and I'm sure you'll understand very well. The pizza that Jose and Tessa are eating has 10 slices and is half cheese and half mushroom. Tessa spins the pizza around and randomly selects a slice of mushroom pizza. If Jose spins the pizza and selects a slice after that, what is the probability that both he and Tessa are selects a slice of mushroom pizza? Now, what's the thing that's happening here? There is totally 10 pizzas, 10 slices of pizza. So 1, 2, 3, 4, 5, and same thing over here. Left of it, let's imagine, is cheese, and over here it's mushroom. Okay, they are going to randomly spin it out. I don't know why did I just scratch. That's very silly of me. Anyways, so now they're going to randomly turn this out and they're going to randomly select one. So first, both of them first will be done by Jose, and then even Tessa also will do that. What is the probability both of them are going to get mushroom pizza? So now the probability of A and B, because here it's dependent, you're going to pick the pizza and going to eat it, you're not going to put it back, right? Will be probability of A and multiplied by the probability of B with the condition that A is done. So what is the probability of A? There are 5 mushroom pizzas, that's the desired outcome, divided by the total possible outcome, 10. Multiply it with probability of B condition A. That means probability of B again, which mushroom pizza itself. So now this mushroom is gone. How many? 1, 2, 3, 4 is remaining. 4 by, now total pieces are 5, 6, 7, 8, 9. Because 1 is gone, so it's 4 by 9. So if you put this in the calculator, that's it. That's your answer. So it'll be over here. 5 times 4 is 20 by 90. So it's basically 2 by 9. This is the probability that both of them, if they randomly select, they're going to select mushroom pizza. That is 2 by 9. Okay. That's the answer. Very simple problem. Over here, they have just written mushroom M, cheese C. You can write it as A, B, anything, it's fine. And the probability is 22%. You will get 0.22, but in percent, it's 22%. Over here, we have another similar problem. On a math test, 5 out of 20 students got all questions correct. If 3 students are chosen at random without replacement, What is the probability that all three got all the questions correct on the test? Okay, now look, the condition is only 5 out of the 20 students got full marks in the math test, but you're picking students at random. Three students, how many? Three students. So probability of first student, probability of second student, probability of third student. All these are dependent. Why? Because all three selected must have full marks in the test. Now, what does this mean? When you're selecting first student, what is the probability that he has got full marks? It's 5 out of 20 because there are total 20 students. 5. That's fine. What is the next probability? Already one student is gone. He is removed away. Is not going to be included over here. So it'll be 4 by 19. Don't forget, because some students make sure they write it 4, but they forget the below denominator. They write 20. That's wrong. Now a student is gone. That means total reduces. Also the above. Both the things reduce. So now it was 4 out of 19, and now this student is also gone, is already once chosen. So what is the probability for the third time? When you're choosing another student, what is the probability that again he will have full marks on math test? 2 are gone, so you're remaining only with 3 by 18 now. Just put all these three numbers in the calculator and you will have your answer. So the answer must be 1 by 114. You can also simplify it over here, because here you have, say, one time, sorry, this is 2 times, 9 times. You know, just tables over here: 2 times 1, 10, 5 times 1, 5 times 2. Now, then this is 3 times 1, 3 times 3. So it's easy to solve this, because it is 3 times 2 is 6. 19 times 6 would be 114. So that will be the answer. It's 0.9%. That's the end of this lesson. I hope you have found it helpful. Please do share the videos with your friends who might find it helpful. Please do like the videos if you have found it beneficial. And if you're not yet subscribed, please do subscribe. Until the next video, wish you all happy learning.